Good day from Chem Help ASAP. In this video we're going to draw the orbital picture for a molecule hydrogen cyanide. So hydrogen cyanide has this simple structure that we've shown in the upper left. Note that we now have a triple bond, and triple bonds consist of 3 bonds. The first is a sigma, and then there are 2 pi bonds. So we're going to have to incorporate 2 pi bonds into our orbital picture. Now, I'm going to want to draw this picture so it extends horizontally across the screen. So I'm going to have to pay attention to that because I'm going to want to use the py to generate our hybrid so we get this horizontal component parallel to the y-axis. So the carbon is sp hybridized. So when we think of S, the px, py, pz, we want to make sure when we make our hybrids, we use that py. So we will get 2 hybrid orbitals, 2 sp hybrids, plus left over our px and our pz. Those are the p orbitals we're going to use to make our 2 pi bonds. And our sp hybrids will sit on the y-axis. So here's our carbon. Our carbon is going to form a bond to the hydrogen using one of its hybrid orbitals. It's going to form a bond to nitrogen, and we'll deal with the nitrogen in a second. And this carbon has left over on it a p orbital, one p orbital right there. That is the pz orbital, and it has another p orbital. This one's going to be harder to draw because I have to draw it parallel to this x-axis. So we'll try to draw one lobe of our p orbital wedged, and the other lobe hashed. That's our px. Now we know that nitrogen, if it's going to form 2 pi bonds with carbon, it must also have these particular p orbitals. So it's also going to have a pz to overlap with carbon's pz. It's also going to have a px to overlap with carbon's px. Now it also has a lone pair. Typically, lone pairs require hybrid orbitals, so the nitrogen, as it makes this carbon-nitrogen sigma bond, that uses a hybrid orbital. We're also going to have a hybrid orbital, a second hybrid, holding that lone pair. So the nitrogen is also sp hybridized. To complete our picture, we simply overlap the ends of our p orbitals. And again, now we have a lot of lines connecting the carbon and nitrogen, 5 in all, but some of those are from our pairs of lines for our pi bonds. So we have 5 lines, but that's really 3 bonds. It's a carbon-nitrogen triple bond. So that is our orbital picture for hydrogen cyanide.